Guys, welcome to lesson 3. This is on angle pairs formed by transversals. So we're going to review some major types of lines here, and just thinking about parallel lines, which the notation we use for parallel lines would be the railroad tracks. So parallel lines are coplanar lines. They're on the same plane, and they do not intersect, and the symbol slash slash means is parallel to. So we could write literally like PW, line PW is parallel to line QX. And there's also other combinations that would work as well. Now, skew lines are lines that are non-coplanar, but they never intersect. So you can think of like an overpass on a bridge. So, for instance, PW would never intersect with line SR. They never intersect, but they're not coplanar. They're not parallel either. Now, parallel planes are planes that never intersect. So we could show when we're naming a plane, it's like a parallelogram, P W Q X. That's this plane here is parallel to S Z Y R. It's parallel to plane S Z Y R. We can think of opposite walls. We could think of the floor and the ceiling as parallel planes. So using diagram, we're going to name some parallel planes. So I see Q, plane Q, R, T, S is parallel to plane U, V, X, W. Similarly, SQUW is parallel to TRVX. A line parallel to RV, so RV is parallel to TX, and it's also parallel to QU. A line that's skewed to WX, so that could be TR, or we could do QS. So we'll say QS. A line that's parallel to the plane QUVR would be plane, or line QUVR could be SW, or any other lines opposite it. A plane parallel to QUWS would be R, plane R, VXT. Okay, so now we're going to go into types of angles formed by lines that are parallel. So firstly, when a line intersects two or more lines, the angles formed at the intersection create a special set of angle pairs. Parts of lines crossed by a transversal. So firstly, a transversal is a line that passes through two lines in the same plane at two distinct points. So this line here is a transversal. This is a transversal. Okay, the difference is that these lines here are not parallel. These are not parallel. But these lines here, we call it A and B. A is parallel to B. And I can tell because there's arrows here. Okay, and when they're parallel, it sets up certain conditions about angles. Things that we already know, vertical angles, are congruent. And if you can't remember what vertical angles are, all I need is some line, and these angles, these opposite angles, are vertical angles. And then if I wanted to show the second set of vertical angles, I would just do two arc marks to denote that these are not equal, but the opposite angles are. Okay, so the first type of angle we'll look at are our corresponding angles. So corresponding angles are on the same side, and these lines are parallel. So we have the first parallel line, and then we have the second parallel line. But they're on the same side of the transversal, but in different positions. So these angles are congruent. Our sets of corresponding angles, we have the measure of angle 1 is congruent to the measure of angle 5. We have other sets of corresponding angles as well. So the other sets, we have two, I want to do a different color. We have two, we have angle 2 and angle 6 are corresponding. We have angle 3 and angle 7. It just needs to meet the conditions where one's on the interior of the parallel lines and one's on the exterior, and they're on the same side of the transversal. So setting this up, I have the measure of angle 4 is congruent to the measure of angle 8. I have the measure of angle 3 is congruent to the measure of angle 7. And lastly, I have the measure of angle 2 is congruent to the measure of angle 6. So the conditions here, one exterior, one interior, so one angle interior, one angle exterior, and on the same side. So 1, 2, 3. These are the conditions for corresponding angles. Consecutive interior angles, these are same side interior angles. So just making sure we understand, here's a transversal, here's my parallel lines. This is the interior, this is the exterior, and this is the exterior of the parallel lines. All right, so consecutive interior means they're on the same side, right? So we have a couple of sets of those. We have this one, 4 and 5, and then we have 3 and 6. And what we can say about consecutive interior angles is that they are supplementary. These are supplementary. Angles, so they add up to 180 degrees. Therefore, I could write the statement, the measure of angle 4 plus the measure of angle 5 equals 180 degrees. Similarly, I could write the measure of angle 3 plus the measure of angle 6 equals 180 degrees. The conditions, 1, same side, 2, in the interior. Both are in the interior. Okay? Next, we have consecutive exterior angles. Similarly, they're on the same side, but they're both in the exterior. They add up to 180 degrees as well because they are supplementary, right? So we have angle 1, angle 8 are supplementary, and we have angle 2 and angle 7 are supplementary. So when I write my statements, I can say that the measure of angle 1 plus the measure of angle 8 equals 180. And I could also say the measure of angle 2 plus the measure of angle 7 equals 180 degrees. Alternate interior angles, angles that lie on either side of the transversal. So let me go back and put the conditions here. Both on same side and both in exterior. Okay? So alternate interior angles are 1 on the inside of parallel lines, 2 on either side of the transversal. So the way I would show it, this angle, angle 4, and angle 5. So the measure of angle 4 is congruent to the measure of angle 5. These angles are congruent. Now, when I want to show the other set of alternate interior angles, make sure you use 2 arc marks because there's a different measure from angle 4 and it's a different measure from angle 5. So the measure of angle 3 is congruent to the measure of angle, oh, I got that wrong. This should be 6 and then this should be angle 5. Okay, alternate exterior, so arc marks, and then 2 arc marks for my other set, and these are congruent as well. So conditions, alternate sides of the transversal, 2 in the exterior. So angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. All right, so keeping that in mind, right? We're going to go on to do some work. So it says choose the words that best complements the statement. So before I go on, I'm going to just write supplementary angles and congruent angles. So we have supplementary would be consecutive interior, consecutive exterior. So add them up, they equal 180. Congruent angles would be corresponding alternate interior and alternate exterior. Okay, so it says if 2 lines are cut by transversal, so that I'm going to highlight this, so that alternate exterior interior angles are congruent, then the lines are parallel. So the correct answer is that they are congruent. If 2 lines are cut by transversal, so that same side interior, so same side would be consecutive side interior angles, they are supplementary. If 2 lines are cut by transversal, so that are congruent, so alternate interior, alternate exterior, so there's 3 choices here, and corresponding, if all of these angles are congruent, then the lines are parallel. If 2 coplanar lines are perpendicular to the same line, so 2 coplanar lines perpendicular, then the 2 lines are parallel. They have to be parallel. Given that A is parallel to B, so I'm going to make the notation for parallel, draw my two arrows. Things I already know. These angles are congruent. Okay. Then I'm going to draw my second sets. These angles in the red are congruent. So if I know that those two lines are parallel, there's a transversal running through them, I can already set myself up for success. Okay. So it says angle 1 and angle 8 has one arc mark. So the postulate for those, what types of angles are those? They're opposite sides and exterior, so alternate exterior angle theorem. Angle 3, angle 7, these are corresponding angles, so corresponding angle theorem. Angle 4, supplementary to angle 6, so they're same side or consecutive interior angle theorem. Angle 3 to 4, this is a linear pair postulate. Angle 7 and 6, vertical angle theorem. Okay. 10, state the postulate or theorem that allows you to conclude that J is parallel to K. So these are alternate exterior, therefore J parallel to K. Here, they add up to 180, so these consecutive interior angles. So J is parallel to K. Here we have alternate, and they're inside of the parallel lines, J and K. So alternate interior angles are congruent, therefore J is parallel to K. Next we have corresponding angles. Congruent, therefore J is parallel to K. And that's how that works, guys. So, when we are operating with this type of thing, all right, we want to separate possible parallel lines. So I'm going to separate those and I'm going to redraw those, and you should do the same thing. So here we have that one, and that one. Okay. Because otherwise you can't see correctly. All right, and then I'm going to do the other one over here. So I have 4 diagrams I need to do here. All right. So let's go ahead and label. I have C, C, and D. have C and D. All right. And then my transversal, my first transversal for C and D is A and then B. All right. Then I have lines A and B and A and B. And then my transversal for these lines, I have line D and then I have line C. All right, so now I can go and write angles in there. So for CD and A, CD and A, I have 1, 2, 5, 6, 9, 10, 13, 14. For CD and B, I have 3, 4, 7, 8, 11, 12, 15, and 16. For ABD, I have 13, 9, 14, 10, 15, 11, 16, 12. For A, B, and C, I have 1, 5, 6, 2, 3, 7, 4, 8. And then what I would do afterwards is go set myself up for success and identify the congruent angles. So angle 1, 9, 19, and 6. 4, 7, 12, 15, 9, 14, 11, 16, 1, 6, 3, 8. Okay, and then let's go do the other ones. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Now, it doesn't mean that all the orange angles are the same. It just means on that particular diagram, they are the same. Doesn't mean that angle 1 is congruent to angle 9 over here, okay? So first, angle 9 is congruent to angle 16. So 9 and 16, we're looking at A and B and D. So A, B, and D. 9 and 16 are alternate exterior angles. Therefore, A is parallel to B. Angle 5 and 7, so 5 and 7, so we're looking at A, B, and C. So A, B, and C. So 5, 7 are corresponding angles. Therefore, A is parallel to B. Angle 14, 16, 14, 16, we're looking at A, B, and D. So 14, 16 are corresponding angles. So A is parallel to B. Angle 1 and 16. 1 and 16. Looking at A, B, and D. So that doesn't work out because when I look at the diagram, I can't prove anything. Can't prove this because it's not on this diagram here. Angle 5 and 10, so 5 and 10, that's A, C, and D. So C and D and A. 5 and 10 are alternate interior. Therefore, C is parallel to D. The only one we couldn't prove is 17. The next lesson is proving lines parallel. We're going to leave it at that, and that's all she wrote. Do the master check number 3. Have a great